let's talk about the architecture of Twingate and what it is today, especially compared to something most people are familiar with, and that would be the VPN architecture or paradigm that most people are familiar with. There are things with VPN that increase your risk as a company or even as an individual. If you're running a home lab, for instance, I used to give this example to people all the time, where before I implemented VPN, or before I implemented Twingate in my home lab, I used to have an open port with a VPN gateway, so I could connect from the outside when I was traveling for work, for instance, and wanted to do something at home. I used a VPN before, and I used to actually monitor how many attacks I would get on various pieces of my infrastructure at home that were accessible through the VPN. And there were about like 30 to 60 attacks a day on that single port that was exposed to the outside world. So that's an obvious flaw of VPN, is to have an open port that accepts inbound connections. Because if there's a bug, if there's a 0-day in the VPN gateway, someone could potentially access the infrastructure that you're trying to protect. The second thing that we see very often is that if you use a traditional VPN, and if it is a full VPN and everything you do on your computer goes through that same gateway, then you're going to typically have poor performance and poor usability of it. If you're on a Zoom call and the Zoom call goes through a gateway and then you disconnect from the VPN, you're going to get kicked out of the Zoom call, for instance. And that's if the Zoom call itself is delivering good quality, because if everyone's using Zoom through VPN, the gateway can only take so much. So full VPN isn't really adapted to the right or adequate end user experience. Not to mention that it does things from a security standpoint that don't actually always make sense. Yes, it encrypts everything, but it mostly double encrypts public traffic that is always encrypted and often not something that you need to worry about at all. The third thing about VPN that doesn't work quite right is that if you manage to gain access to a gateway, if you have credentials for that VPN gateway, then you gain access to the internet or the private network. But very often, if you have access to the private network, you have access to everything on the private network, because a VPN implements a model where if you're in, you're really, really in. And that could be seen as a problem in some cases. The fourth point is that when you deploy a VPN, you don't always have an ability to verify things about the device that is connected to your VPN. Maybe you want to allow only certain operating systems. Maybe you want to make sure that the device has been pre-approved, that nothing else, even with the right credentials, can get in and connect to anything. Maybe you want to make sure that people have biometrics activated, a firewall, and so on. None of those things typically are part of a VPN architecture. The fifth one is that with a VPN, it's not always easy to protect a public access, a public resource like Snowflake or GitHub. Because it doesn't live with you, it doesn't live in your private environment, a VPN is only going to do so much towards implementing stricter security control for stuff that's hosted in the cloud. So all of those things, on top of the usual lack of automation capabilities of VPN, is what Twingate sets out to solve. Now, we'll take a look at some of the components in Twingate that make it possible. But it's really, I think, more interesting to go and talk about those components individually to understand how Twingate delivers value well beyond a VPN. So we'll go into a live architecture diagram. So there are 4 components to the Twingate solution and only 2 components that you need to host and deploy yourself. The first component that is probably the most common one is the client, the Twingate client. The Twingate client is available on Mac, it's available on Windows, on Linux, it's available on Android, iOS, And you can get it simply by going to twingate.com/download. I believe if you do get.twingate.com, it redirects you there as well. So you can deploy it within seconds on really any operating system. The client is what end users are going to use to gain access to your remote and private resources that you're trying to protect. So you can deploy it, you can install it manually, you can deploy it using any MDM tool, pre-configure profiles, and so on. The second component that you're going to have to install behind the firewall is called the connector. You're very likely going to install several connectors, much fewer connectors than clients. But what the connector is essentially a very small piece of software that gets deployed in a container or in a VM that acts as a proxy for connections coming from Twingate clients and communicates itself with the endpoints that you're protecting, whether those endpoints are private or public. Actually, it makes no difference. Now, you're going to deploy connectors within what we call remote networks, but a remote network is really nothing more than just a logical group of connectors that are going to broker connections to the same resources. And all of the connectors within a remote network are going to provide native high availability and load balancing without you having to do any of the configuration for that. All you have to do is deploy the connectors, make sure they're part of the same remote network, and that high availability load balancing is done for you. Now, you're very likely going to have more than one remote network unless you're a home lab user. But think of your remote networks really as just logical partitions of your network. You can create as many remote networks as you need and as few as you need. And same with the number of connectors. You can scale beyond 2 connectors if needed, but it's almost never the case that you will need more than 2 connectors within a remote network. Although we do recommend 2 connectors because it, again, provides high availability and load balancing. You can deploy connectors by running commands on servers or spinning up containers. You can also deploy connectors by using Terraform, using Pulumi, using the API. There's all sorts of ways that you can deploy connectors. It's a very flexible deployment model. The other 2 components that really you don't have to worry about at all because they're hosted by Twingate are the relays and the controller. So think of the relay as a worldwide facility that's available on all continents that is there for the primary purpose of allowing your clients and connectors to establish a peer-to-peer TLS-pinned tunnel. That's the purpose of the relay. We don't obviously want any inbound open port through your firewall because, again, it's a very big security risk. And so in order for us to avoid having to poke a hole in your firewall for clients to be able to connect to connectors, we use the relay infrastructure, and so we maintain it for you. The way the relay works is it uses a technique called NAT traversal off of the STON protocol, where both parties, the client and connectors, communicate with a relay. The relay exchange information between client and connectors so that they can establish a tunnel without ever requiring any inbound port open on either side of the tunnel. That's what the relay is for. Again, it's available worldwide, and you don't have to worry about the relay because it's maintained by Twingate, hosted in GCP worldwide. The fourth and final component is what we call the controller. The controller sees none of the data. The controller is the control plane of Twingate. The controller is the brains of the operation. It is what tells your clients what resources they have access to. It is what checks in on the identity provider to make sure that the identity one of your users is using to connect to your infrastructure via a client is a legitimate identity known by the identity provider. That is what the controller is. Again, this isn't a component you need to worry about because you don't need to host it yourself, but it's interesting to know where those decisions and verifications are made. Now, there's a 5th component, but you don't need to deploy it, and it's not a Twingate component, but it is a good one to know of. It is the identity provider. So we support multiple identity providers, G Suite or Workspace nowadays, Entra AD, formerly known as Azure AD, Okta, OneLogin, Keycloak, and JumpCloud. And this means that the concept of identity handled by the identity provider is inherited by Twingate. So Twingate can pull the list of users from your IDP, can pull the list of groups of users from your IDP, and those live in Twingate and are given rights and assigned policies. So it's an easy way for customers to not have to reinvent identities, because the source of truth for an identity is usually already defined in the IDP. It makes the configuration of users and groups very, very simple, in fact. And that is pretty much it for the overview of the infrastructure. Now, one thing to know is that there are some prerequisites for the connectors and for the clients. For the clients, the prerequisites are obviously internet connectivity. That's pretty much it. For remote networks and for connectors, the prerequisites are that the connectors there is no need for anything open inbound, but the connector needs to be able to connect outbound to the relay facility. And so it needs TCP outbound access over port 443, port range from 30,000 to 31,000. And it needs to be able to communicate over UDP on all outbound ports. And the QUIC protocol needs to not be blocked by your firewall, because the peer-to-peer communication between client and connector uses UDP and uses QUIC. We use QUIC for performance reasons. It's very fast compared to anything else. Note that if you block QUIC or have an actual need to block QUIC and don't want to rely on peer-to-peer, that's okay. The secondary role of relays is that if a peer-to-peer tunnel cannot be created between the client and the connector, then the connection is relayed through our relay infrastructure. Again, encryption is handled by the client and connector, two components that are within your control. And so therefore the relay cannot intercept or decrypt any communication. And the relay is absolutely stateless, so it logs nothing of the communication between the components of Twingate. Now, how this translates into the admin user interface is that your users and groups are typically going to exist under users and groups here. They're all manual in Twingate. You have the ability to create your own groups, but again, you can inherit groups from your IDP, so you could actually do a combination of both of those things, and that's where they live in Twingate. You're going to also see under network and remote networks, your remote networks and all of the connectors that you have deployed. So this connector, for instance, seems to be deployed on AWS with a particular private and public IP. And it's reporting to the two other elements that we mentioned, the controller and relay, as being connected. So that's where all of this stuff lives within the admin console itself.